Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. The sky above you is quiet, not just quiet in sound, but in movement. It feels still, eternal, but this stillness is only how your eyes tell time. Beneath the silence, something much deeper is happening. Every point of light overhead, every star, every galaxy is drifting, not in the way wind carries leaves or rivers carry silt. No force pushes them through space. Instead, space itself stretches, light fabric, pulled slowly at the edges. And the galaxies, resting upon that fabric, move with it. You float in this stretching. You don't feel it, not in your bones, not in your breath. Yet every cell in you is part of this expansion. Your atoms once came from stars that were born when the universe was denser, smaller, hotter. Now, those stars grow distant, and the light they gave you moves further away with each passing second. The ancient astronomers didn't know this. They looked up and saw a dome, a perfect, fixed ceiling of stars. Even centuries later, people still imagined a clockwork cosmos, planets wheeling predictably around a motionless Earth. Even when Earth fell from the center, the universe itself remained still, or so we thought. Then came the telescopes. Then came the light. When scientists first pointed glass toward the stars, they expected beauty. They found it, but also something else. They found red dot, not the red of a flame or the red of blood, but red as a fingerprinter shift in the color of starlight, a stretching of its waves, like the low moan of a siren that's driving away. This shift meant something bold. The galaxies weren't holding still. They were moving, fleeing, and the farther they were, the faster they went. Imagine a balloon, tiny dots drawn across its surface. As you inflate it, the dots grow farther apart, not because they move, but because the surface itself expands beneath them. This, scientists said, is what the universe is doing. And so, you live in a universe that grows, not outward like a ripple in a pond, but in all directions at once. Space itself, like breath, gently and endlessly exhaling. But then came a whisper of something stranger. Not only is the universe growing, it's growing faster than before. It's not just stretching, it's accelerating. This is the mystery that cradles you tonight. Force, a presence, a rhythm in the dark that speeds the universe apart, even as gravity tries to pull it back together. You don't feel the acceleration in your skin, but it surrounds you. Imagine two galaxies like ships on a gentle sea. They once sailed closer, but now the water between them deepens, widens, grows colder, not because either ship moved, but because the sea itself shifted. This sea is space, and something in it, something silent, pushes it wider and wider. Even now, you are part of this story. You're not on the sidelines of the cosmos. You are woven into it. Your breath carries atoms born from stars that once stood closer to each other than they do now. And every second that passes stretches those spaces farther still. It can feel unreal, unfelt, but that's only because the scale is too vast for your senses. If you lived for billions of years, you would see galaxies drift like petals tossed by a hand you cannot see. And that's the heart of this mystery. There is a hand, metaphorical, of course, but no one knows what it is. It's not gravity. It's not matter. It's not anything we can touch. We gave it a name, dark energy, not because it's malevolent, not because it's shadowed, but because it hides from view, because it acts, and we can't see the actor. You feel none of its weight, yet it may carry most of the universe, makes up more of everything than stars, gas, dust, or planets. more than the galaxies combined. And yet, you cannot catch it. So, you lie back beneath the expanding sky. The stars don't whisper their distances to you, okay? But they do glow. And that glow carries a message. They're leaving, not from fear, but because the fabric of space is shifting beneath them. It's like watching dancers on the floor that slowly, gently grows. Each step takes them farther, though they move the same. This expansion is old. It began in the earliest seconds of time. For a long while, gravity pulled against it. Matter clumped, stars formed, galaxies spun in spirals of light. But as the universe grew, matter thinned, gravity's tug weakened, and dark energy, whatever it is, rose into dominance. It now shapes the destiny of everything, not with force, but with distance, with the growing quiet between stars, okay? With the thinning light of the cosmos. You cannot feel that distance as you drift toward sleep, but it is there. It is always growing. The silence of the universe is becoming deeper, the light more faint, and yet, somehow, the mystery more vast. Your place in this expanding dream is real. You are not outside of it. You are inside the motion, floating on the breath of space itself. And as you exhale, perhaps the universe does too. A long, slow, stretching sigh carried out across eternity. The stars above you seem still, but now you know stillness is an illusion. The galaxies are sailing away, carried not by wind, but by something deeper than wind, something we still don't fully understand. And as your thoughts begin to quiet, you wonder, what did we once believe the universe would do? You close your eyes, floating now in the dark expanse of thought. The sky still breathes around you, slow and soundless. And as you drift deeper into the question, what did we once believe? You return to a time when the universe was simpler, or so we thought. There was a comfort in old assumptions, quiet logic. We knew gravity. We knew mass. We understood that what rises must fall, and that all things eventually slow. The universe had exploded into being, yes, a bright, hot, expanding fireball. Over time, scientists imagined the force of gravity would begin to pull it all back in. Stars would tug on stars. Galaxies would reel each other closer, okay? And perhaps, after billions of years, everything would return to a central point. This idea made sense because gravity is persuasive. It is the gentle hand that shapes galaxies, the unseen arm that keeps planets loyal to stars, moons bound to planets, and oceans to Earth. Surely, gravity would not let the universe drift apart forever. Surely, this expansion would slow, just as a ball thrown into the air begins its graceful fall. That was the dominant picture. Two possible endings, both framed by gravity. One was the big crunch. The universe would reach a maximum size, then reverse contracting inwards until everything collapsed into a fiery end, a mirror of the beginning. The other was slower, more peaceful, eternal expansion, but gently decelerating like a car coasting to stillness at the edge of the road. In both views, the key force was known, predictable, named gravity. So astronomers set out to test this cosmic fate. They looked deeper into the universe, which also meant further into the past, because light travels across time. And the objects they chose to measure were the most dramatic lighthouses in the sky. Type Ia, supernova. These are not ordinary stars. They are explosions flares, so bright they can outshine an entire galaxy. And their power is consistent, like candles that always burn with the same flame. This consistency meant that if a supernova appeared dimmer, till it must be farther away. If it appeared brighter, it was closer. It's like judging the distance of a campfire by its glow dot. So, in the 1990s, astronomers began collecting these flames. They measured dozens of supernovae, gathering their light from distant corners of the cosmos. They expected a pattern. The farther away the supernova, the slower its galaxy would be moving, slowed by gravity's pull across billions of years. But what they found was not slower motion. They found something impossible. The distant supernova were dimmer than expected, much dimmer, which meant they were farther than they should have been, which meant their galaxies had moved more, not less. The universe wasn't just expanding, it was speeding up faster and faster, like a ball thrown into the air that suddenly takes off like a rocket. This moment, this quiet, numerical shock rippled through science. It was 1998, and everything we thought we knew. So Ted, imagine expecting a sunset and getting dawn instead. That's what the data said. The cosmos wasn't slowing down. It was accelerating outward. Galaxies weren't falling back. They were fleeing, driven by a force that no one had planned for. Some scientists checked the numbers again and again. There must be a mistake. Others felt a chill because the universe had just spoken. Not with words, but with the dim light of ancient explosions. And its message was clear. Something unseen was at work. Something powerful, pushing everywhere. It was not the result of galaxies moving through space. It was space itself growing faster, and no known force could explain it. The implications sank in slowly. A cosmic force we had not seen, not measured, not even guessed, was in control. The term we gave it was soft, almost gentle, dark energy, but it meant more than mystery. It meant surrender. It meant the universe was governed by something outside the laws we trusted. Gravity was no longer king. Matter was no longer the architect. Something quiet had stepped in, and it was shaping the fate of everything. Back then, people had used terms like deceleration parameter, a way to measure how much the expansion was slowing. Now, they had to rewrite the equations, not just the numbers, but the story. Because science is not only facts, it is the tale we tell ourselves about how the world works. And that tale had changed. There were scientists that built their lives on the idea of a slowing universe. Now, they stood in lecture halls, adjusting slides mid-sentence, trying to describe a force they couldn't picture. And yet, they were also in awe. Because isn't this why we search? Not just for answers, but for the questions that change us. Dark energy wasn't a theory born in a lab. It was written into the stars, revealed not by intention, but by listening carefully to the softest light. From the farthest places, it is humbling to be wrong, but it is also beautiful to know that nature still holds its secrets close, to learn that we are still at the beginning of understanding something as enormous as the fabric of reality. The acceleration of the universe told us something else. Too, it told us that time itself might behave differently than we had believed. That the future is not governed by gravity alone, but by a force that increases with distance, a force that does not weaken, but becomes more dominant as the cosmos stretches wider. In the past, matter ruled. Galaxies were packed close, and gravity had power. But as the universe grows, dark energy becomes more and more influential. It's like a gentle whisper that becomes the only sound in a vast room. Tonight, as you rest beneath that growing quiet, you are held not only by gravity, but by something else. A presence, perhaps. A pressure. The fabric of space wants to stretch. And the more it stretches, the more it wants to. There's no tension you can feel, no vibration in the air, but the mathematics are unyielding. The distance between galaxies will keep growing, and the rate of that growth will increase. The expansion is not a line. It is a curve, steepening one. And that curve is the signature of something we still don't understand. Maybe we never fully will, but we continue listening to supernova, to the echoes of the early universe, Tina, to the signals woven into background radiation, Tina, to the slight, precise shifts in cosmic structure that reveal how space changes shape. In all of them, this unknown energy leaves its fingerprints, faint but undeniable. And as you drift towards sleep, return to that quiet image. Galaxies, like lanterns, carried outward by a rising tide of space itself. What we once thought we knew was only a chapter, and now, new one begins, written in shadows, measured in light. What is this force that shapes the cosmos? Okay? And how do we even begin to define it? You open your eyes again, though they never truly closed. Just beneath the lids, the universe kept shifting. Tonight, return to a moment, not billions of years ago, but only decades back. A moment when science quietly paused, and no one quite knew what to say. The year was 1998, the end of one century, the cusp of another. Astronomy, by then, had grown precise. There were telescopes that could look not only across space, but across time itself. The light from faraway galaxies does not travel instantly. It moves slowly, faithfully, crossing oceans of darkness, carrying messages from the past, and astronomers had learned to read those messages, to decode the fading fingerprints of ancient explosions marked in wavelengths and shadows. That year, two teams were racing quietly, though they didn't call it a race. They were hunting for certainty, using some of the brightest lights in the universe to test a single, beautiful question. Was the expansion of the universe slowing down? It was a logical assumption. Gravity pulls, it has always pulled. Stars collapse under it. Planets orbit because of it. Why wouldn't it also slow the grand expansion of everything? They chose their tools with care. Type Ia supernova. These are not gentle events. They are the deaths of stars in binary systems, two suns orbiting each other, until one steals mass from its companion and ignites a runaway collapse. And yet, in their violence, they offer peace to science, because their brightness is reliable. They explode with almost identical luminosity, no matter where, no matter when. Like street lamps in the dark, you can tell their distance by how faint they appear. These cosmic candles had become a kind of ruler. A tape measure stretched across the sky, and as each team collected data from Chile, from Hawaii, from orbiting telescopes above the clouds, they expected to find evidence of a universe easing down, its expansion dragging its feet, like a runner losing breath. But something strange crept into the data. Not once, but again and again. The supernovae were dimmer, too dim, which meant farther away than they should have been. In their host galaxies, rather than lagging in their outward flight, were accelerating, moving faster, carried on a wind no one had predicted. Astronomers are used to quiet. They work in silence, in darkened rooms, eyes fixed on screens displaying the ancient light of stars long extinguished. But this silence was different. It wasn't the silence of study. It was the silence of being overturned. It is not easy to rewrite the architecture of everything, because that's what this meant. If galaxies were accelerating away from each other, then some force was acting upon space itself. Something repulsive, something powerful, something completely unaccounted for in the models they trusted. And it was not a fluke. Both teams saw it independently. They checked for errors, redid the math, adjusted for dust, for interference, for every variable they could imagine. Still, the result whispered back. Unchanged, the universe was accelerating. And then came the day when it became official. At a scientific conference in front of peers and skeptics, the teams presented their findings. Some sat quietly, some leaned forward, others leaned back. One observer would later say, it was like watching the floor of reality shift. There was no thunder, no announcement of revolution, just numbers, graphs, like curves on a screen. But beneath those numbers was the collapse of certainty. The sky had changed. Not the stars, but the rules beneath them. And those rules had no name. Soon, a name would be given. Dark energy, not because we understood it, but because we didn't. Dark, not in color, but in knowledge. Energy, not because it was well defined, but because something was making the universe move faster. The term filled the gap between understanding and awe. Scientists, for a moment, were stunned. Then the papers were written. Then the Nobel Prizes came. But that was later. In the moment itself, there was only silence. Not fear, not confusion, but a kind of reverence, because something immense had just spoken. And it had done so through flickers of light from 1 billion years ago. Pause. Here, let your mind float. Imagine a star exploding, not now, but 10 billion years in the past. Its light travels, crossing space, crossing time, passing galaxies, dust clouds, comets, the cold edges of clusters, until it reaches Earth, until it reaches a telescope, a sensor, a human eye, and that tiny glimmer, that dying light, says something no one expected. It says, everything is drifting faster than it should be. It says, the sky is flying apart. It says, you were wrong, but beautifully so. This is how science grows. Not in the comfort of being right, but in the courage to listen when nature says otherwise. The astronomers were silenced. Not in failure, but in awe, and the questions that followed were larger than ever before. What is dark energy? Where does it come from? Why now? Why does it seem to rise in influence just as matter begins to spread thin? Or something alive, shifting slowly with the age of the universe? Is it woven into the fabric of space itself? Or is it something outside, pressing inward? Or maybe outward? No one could answer, but the silence had already changed things. It was not empty. It was full of possibility. Since then, every map of the cosmos has included dark energy. It makes up more than 2/3 of the total contents of the universe. More than stars, more than dust, more than black holes, more than anything we can touch. And yet, no one has ever caught it, trapped it, measured it in a lab, felt its weight, or heard its hum. It remains a whisper, a pressure, a curve in the numbers, presence inferred, not seen. And so, you drift in this idea, dark energy exists, or so the data says, yet you cannot name what it is. Perhaps that's okay. Perhaps mystery is part of the design, because it keeps us looking, keeps us gentle, keeps us open to wonder. The astronomers weren't silenced forever, but in that moment, in that still, data-filled moment, they looked up, and for the first time in a long while, did not have an answer. Only questions, and the quiet of the stars. And you, too, float now on the same unknowing. You lie beneath the same sky, a little older, a little wiser, and more beautifully unsure. You let the light of ancient supernova bathe your thoughts. Listen, because next, we must ask, if dark energy cannot be seen, what exactly is it made of? You lie still. The room around you is calm, but your mind moves softly across a different silence, a deeper one, stitched into the very air between galaxies. Something is there. You can't see it, you can't hear it, but the universe responds to it. It's like a forest to wind, it's like a sail to breath. This is dark energy, and to understand it, or rather, to begin to understand what we don't know, we must sit with absence. We must allow quiet questions to float longer than loud answers, because dark energy isn't a thing you can hold. Not a particle. It doesn't shine. It doesn't weigh. It doesn't even clump or gather like matter does, but it acts, and its actions are impossible to ignore. It stretches space. It accelerates the expansion of the cosmos. It flows, not toward things, but away. It is not gravity's cousin. It is its gentle adversary. Imagine you are in a field at night. Everything is still. Then the grasses begin to bend. Not sharply, no gust. It's just a soft, unseen drift. You can't hear wind. You can't see it, but you know it's there because of what it does. This is how we know dark energy exists, okay? What it does to the universe. And what it does is accelerate space itself. Think of this. In most cases, adding energy to something makes it more active, more compact, more dynamic. Heat makes water boil. Fuel makes engines run. But dark energy does something opposite. It makes space expand. Not locally, not between you and your book or your lamp or the moon, but across the vast canvas between galaxies. It pushes everything apart, without touch, without noise, without beginning, it seems, and possibly without end. What is it? One theory says, maybe it's a constant, something built into the fabric of space itself, even when space is empty. Even when there are no particles, no heat, no light, there is still energy. This is not science fiction, it's quantum mechanics. In the vacuum of space, particles constantly pop in and out of existence. Virtual particles, pairs of opposites, positive and negative, appearing and vanishing in fractions of seconds, so fast they can barely be said to exist at all, but their flickering may leave a trace, like echoes. In a canyon, these ghost particles hum with energy, even when they're not fully there. Maybe dark energy is this background hum, this jittering sea of quantum whispers. But here's the problem. When scientists try to calculate how much energy this vacuum should hold, the answer is wrong. Not a little wrong, not 10 times or 100 times off, but off by a factor of 10. That's a number with 120 zeros. The largest mismatch between theory and observation in all of physics. It's as if you measured your living room, got the size of the entire observable universe. That can't be right. So maybe the vacuum explanation isn't enough. Or maybe our math needs refining. Or maybe something deeper is waiting to be discovered. Other scientists think dark energy might not be constant. Maybe it's a field, something dynamic, something that changes as the universe evolves. They call it quintessence, a poetic word, a callback to ancient philosophy. In the days of Aristotle, quintessence was the fifth element, beyond earth, fire, air, and water. It was the material of the heavens, the stuff of stars. Today, the name lives on in a different kind of mystery, a force that fills space, changing slowly, perhaps, like the temperature of deep water or the pressure inside a sleeping planet. If dark energy is quintessence, then maybe it was stronger once or weaker. Maybe it shifts as space stretches. Maybe it flows, but we don't know. We try to measure it. We look for patterns in the way galaxies arrange themselves. We observe the brightness of ancient supernova. We listen to the whisper of the cosmic microwave background, the afterglow of the Big Bang. We compare the ages of stars with the distances their galaxies have traveled, and still, all we really see is what dark energy leaves behind, like footprints in fresh snow, like rings on still water, but not the thing itself. It is, perhaps, the greatest game of hide and seek ever played, and it doesn't need to hide, because we don't yet know what we're looking for. The truth is dark energy may not be a single thing. It may not have a tidy definition. It may not be like anything we've ever found before. It could be a property of space, or the influence of another dimension, or the effect of a quantum field we haven't yet named. It could even be that we've misunderstood the rules of gravity on very large scales. In everyday life, gravity feels reliable. It holds your feet to the ground, keeps planets in orbit. But what if gravity behaves differently across billions of light years? What if, at the scale of the universe, it changes its rhythm, and what we're calling dark energy is really just gravity misunderstood, tumbling? It's dizzying, and it's beautiful, because not knowing is part of the journey. Tonight, as you rest beneath your quiet ceiling, you are suspended in this cosmic mystery. You live in a universe where most of what drives expansion is invisible. And yet, you are not separate from it. You are stitched into that mystery. Your atoms ride the wave of space expanding. Your thoughts drift in the direction of questions still unanswered. You are, in a sense, a part of dark energy's story, just as it is a part of yours. And though you may never feel it, it moves through you, around you, beneath the laws you take for granted. It cannot be bottled. It cannot be caged. But its effects are real. It's what keeps the galaxies moving. It's what paints the distance between stars. It's what ensures that the night sky is not the same sky that was seen a billion years ago. And yet, for all its reach, dark energy remains quiet. It doesn't crash. It doesn't shine down. It doesn't ripple with force like a wave hitting the shore. It simply is, like a breath the universe hasn't yet exhaled. As you drift deeper into stillness, you begin to wonder if this invisible pressure fills space so completely. What happens to the space itself? Does it stretch forever? Does it thin out until stars vanish from view? Or does space have limits, edges, rules we haven't yet discovered? Maybe the key to dark energy is not in what it is, but in what it does to space itself. There's something comforting about simple objects. It's the curve of a balloon, the feel of it in your hands. It's the way it stretches softly as air flows in. Tonight, you hold that image gently in your mind, not as a toy, not as decoration, but as a model for something far greater, a metaphor for space itself. Imagine a balloon, one of those soft, round ones, quiet, weightless, waiting. Now picture tiny dots drawn across its surface, black ink, steady hand. Each dot stands for a galaxy. In the beginning, the dots are close, sitting together in tight company there. Distances small, their futures entangled. Then, slowly, the balloon begins to fill. You breathe into it, gently. And as the surface stretches, the dots drift apart. They are not moving themselves. They do not crawl, or fly, or race. It is not their own energy that carries them away. It is the balloon. It is the space beneath them, expanding invisibly beneath their feet. This is the image that helps us understand what the universe is doing, okay? And what dark energy might be. Because our universe is not expanding like an explosion, flinging shrapnel through air. It is not a firework, not a wave, not a gust of stars launched into space. It is space. And space itself is stretching. You are not watching galaxies race outward. You are watching the stage grow bigger, and the actors drift with it, just like those dots. The balloon analogy doesn't explain everything, but it gives your mind something to hold. In this analogy, our three-dimensional universe is like the two-dimensional surface of a balloon. You don't think about the inside of the balloon or the air within. You stay on the surface, where the galaxies live, where distance grows not because of speed, but because the canvas of reality expands. This image answers a gentle puzzle. Why do all galaxies appear to move away from us? Because from every point on the surface of a balloon, as it inflates, all other points seem to recede. There is no center, it's no special spot, it's no preferred place in the fabric of space. Everywhere expands. Every dot drifts from every other, not because the dots are chosen, but because the balloon is breathing, and dark energy, whatever it is, may be the breath, the force behind the stretch, the invisible motion that fills space with more space. It doesn't make noise. It doesn't have fingers or wind, but it acts consistently, everywhere, quietly. It is the most dominant component of the universe today. And yet, we don't know how it works. Still, the balloon helps us see that galaxies don't need to move through space to get farther apart, because space itself is changing. Imagine a loaf of raisin bread rising in the oven. As the dough expands, the raisins separate, not because they move, but because the bread carries them apart. That's how galaxies behave. In the balloon, it helps remind us of this simple truth. When the medium expands, so does the distance between the things within it. Dark energy isn't shoving galaxies around. It's shaping the canvas, altering the size of the ruler, stretching the cloth, and the more it stretches, the more space there is, and the more dark energy fills it. Because here's another layer to the mystery. Dark energy doesn't thin out as space grows. It doesn't dilute, stays. That means, as the universe expands, there's more dark energy. It's not because it's being created, but because there's more space for it to occupy. This is different from matter. If you double the size of a room, the air gets thinner. The particles are spread out. The density drops, but dark energy remains constant. Same density, more volume, more total dark energy. It's as if the balloon, as it inflates, creates more breath to keep filling itself. And so the process accelerates. A feedback loop. More space, more dark energy. It's more dark energy, more expansion. A quiet runaway motion. Slow, subtle, inevitable. You return to the image, a balloon in your hands. Add breath. The dots move away. They don't resist. They simply follow the growing skin beneath them. You add more breath, they drift faster. The stretch continues, but here's where the metaphor meets mystery. Because in the balloon, you are the breather, okay? A mouth, a will, a choice to inhale and release. But in the universe, there is no mouth, no lungs, no central puffer pushing the cosmos outward. So what fills space with space? What breathes? Some say it is the cosmological constant, Einstein's quiet term. Once discarded, now resurrected. Others say it is quintessence, a field with its own pulse. Some say it is vacuum energy. Some whisper of multiverses, but no one can answer with certainty. So for now, we hold the image, with the dots, the balloon, the quiet expansion, and we let the simplicity guide our understanding. Let's look closer. Imagine you are a dot on that balloon, not a galaxy, just you. It's floating, anchored to the surface dot at first. Nearby dots seem close. You wave. You notice patterns, constellations, neighbors. Then the balloon begins to grow, slowly, then faster. You notice the dots shrinking in brightness as they move farther. The space between you grows dot, and soon the sky looks lonelier. That is what the real sky is doing. Galaxies are not just getting farther apart, they are disappearing beyond reach, because there is a horizon in space. A limit, not because of distance, but because of speed. If the balloon expands fast enough, some dots move away faster than light can reach you. Not because they are faster than light, but because space itself grows faster than light can cross. It doesn't, and so they vanish. Not in fire, but in silence. The universe becomes a quieter place. In billions of years, an observer in our galaxy may see only emptiness, because all the other galaxies will have slipped beyond the cosmic horizon. Still, they're still shining, but unrecoverable, like ships beyond the edge of sight, like candles blown out by a wind you never felt. And that wind is the breath behind the balloon. Dark energy. We still don't know where it comes from or why it acts the way it does, but we do know how it feels, not to the skin, okay, but to the structure of the cosmos. It feels like distance. It feels like acceleration. It feels like time pulling things apart, not by force, but by design. As you drift closer to sleep, imagine this. The universe doesn't expand into anything. It creates its own space. The way a balloon's surface grows, without needing a container. It needs no walls, no edge. Just a rule that distance increases and the dots grow lonelier. But you are still a part of it, still stitched to the surface, still sharing that silent motion. And though you cannot stop the breath, you can listen to it, because next comes a deeper question. If space itself stretches, does that mean space is alive? What is this thing we call space? What is the fabric we all drift upon? You have heard it before. Space is vast. Space is cold. Space is empty. But tonight, you allowed that idea to unravel, like thread slipping from a quiet spool. 'Cause what we call space is not just a backdrop. It's not just a silent container holding stars. It is something more. It is the stage, but also the motion, the rhythm, tease, the breath between all things. And it stretches, not as a metaphor, not as poetry, but truly, physically space itself grows when you think of distance. You might think of stepping forward, of crossing ground, of movement, but imagine instead that the ground beneath your feet expands as you walk, that each step stretches the path itself. This is what the universe does. Galaxies don't race through space. They're carried by it, as if resting on a tide that no one can see. And here is the strange truth. You can remove every planet, every star, every galaxy, every atom, and there would still be space. And that space, even when empty, would still stretch. This is one of the quietest, most unsettling discoveries in science, that nothingness is not still. It breathes, expands. It has a kind of restless architecture. Imagine a vast, dark canvas, blank, silent. Now, imagine the canvas growing slowly, endlessly. It doesn't stretch because of weight or heat. It stretches because that's what it does, because something in its nature tells it to. And that something is what we call dark energy. It's not poured into space. It's not added like water into a bowl. It is the bowl, or perhaps more accurately, it's the material the bowl is made of. You may ask, how can nothing have energy? But in physics, empty space is never truly empty. It seethes quietly with quantum fluctuations. It contains potential. It possesses geometry, and in this geometry, the lines of how things can move, how gravity bends, how time flows. Dark energy is etched. It's not a visitor to space, okay? It is a quality of space. This changes everything. It means that expansion is not caused by something inside the universe pushing outward. It is the universe. It is how space behaves when left to itself. When unopposed, it grows. Just like a balloon inflates, not because the dots move, but because the surface itself expands. Now, let's sit quietly with this idea. If space stretches on its own, if the vacuum naturally wants to grow, then dark energy might not be a force in the traditional sense. It might not act on space. It might be space. This is a shift so gentle, you might miss how enormous it is. It's like learning that the ocean isn't just filled with waves. It is waves. That silence isn't absence. It's part of the music. Space, in this view, is not a flat, neutral ground. It has structure. It has preference. It has energy that we cannot remove. Even in the emptiest regions between stars, it's there in the voids, those massive, dark gulfs between galaxy clusters. Vast, quiet realms that seem to hold nothing. But even there, the stretching continues. That is dark energy. It's not something you find in addition to space, but something space does. So what happens as more and more of the universe becomes empty? As stars burn out, as galaxies drift apart, as matter thins, dark energy becomes more dominant. Its voice doesn't grow louder. It just becomes the only one speaking. Gravity becomes weak across those great distances. I cannot hold galaxies together forever. And as time rolls on, the cosmos moves from a universe of structure to a universe of silence. A future not filled with explosions and collapse, but with the soft, slow unraveling of distance. Because space does not need permission to expand. It expands because that is what space does when governed by the laws of our universe. And we, tiny passengers on this stretching fabric, feel none of it directly. No sensation in the skin, No tug at the edges of thought, but we see it in the sky, in redshifts, in dimming lights, okay? In the math of cosmic maps. And we see it in our models, those carefully built frameworks of what the universe contains. When we draw that pie chart, dividing the universe into parts, dark energy is the biggest slice, about 68%. The rest is dark matter, which we also don't fully understand. And then a thin sliver, just 5%, is ordinary matter. Everything we can see and touch, everything we have ever known. Stars, planets, oceans, light, you, only 5%, and yet that's all we've ever experienced. The rest is hidden in shadows, in silence, in stretch. Dark energy doesn't just explain expansion. It's fate's the ultimate fate of everything. Because as long as it remains, space will keep growing. Galaxies will slip farther apart. Eventually, so far that their light will no longer reach each other. A lonely future. Not violent, but still unsettling. And it all begins with the idea that space itself is not passive. It's not a quiet hallway we walk through. It's a living architecture. Its blueprints include a tendency to expand. The phrase scientists use is metric expansion of space. The metric is the way we measure distance. And that measurement isn't fixed. It grows, not because anything pushes it, but because the very rules that define space are written to allow it. This idea, first born from Einstein's equations, was once just a curiosity. Now it is a pillar of our cosmic understanding, and still we don't know why. We can't describe how it works. We can measure its effects, but the why remains untouched. Like a bird you hear in the trees but never see. It's that mystery that makes this story beautiful. The humility of not knowing. The patience of looking anyway. Tonight, as your thoughts slow, you float on a fabric that expands beneath you. Don't feel it, but you are part of it. Every cell in you, every molecule, every moment of your life is stretched across time on this breathing backdrop. And dark energy is the name we give to this breath we don't understand. The next time you look up at the stars, remember, you're not just looking into space. You're looking at it. The space itself is moving, carrying stars with it. It's carrying you with it, and beneath that motion is a question. If space can stretch, if it has its own energy, can that energy change? Can it grow stronger, weaker? Can it shift like weather? What if dark energy isn't constant? What if it evolves? What if it breathes differently as the universe gets older? It's older. The great theories often begin not with certainty, but with balance. A quiet attempt to steady the world, to align the numbers with the stars above them. Tonight, you sit beside one such moment, an old equation, a name that needs no introduction, in a tiny terms, small and quiet, that would echo across a century. Einstein's field equations, published in 1915, were revolutionary. They rewrote gravity, not as a force in space, but as a curve of space. A bending of the universe in the presence of mass. Planets followed not invisible strings, but the dips and folds in the very fabric beneath them. It was elegant. It was strange. And it worked, but there was a problem. Einstein wanted the universe to be still. At the time, the idea of an expanding cosmos had not yet arrived. Telescopes weren't deep enough. The galaxies had not been measured. And most scientists assumed the universe was static and changing, balanced. So Einstein adjusted his equations, just slightly. He added a small term, fix, a whisper of a force that could counter gravity on the larger scales. This term was called lambda. The cosmological constant. It represented a repulsive energy inherent to space itself. It's a kind of built-in pressure that could resist collapse. With it, his equations allowed for a static universe. Without it, everything would fall inward or drift away. Einstein introduced the constant, not because he had evidence for it, but because he wanted balance. And then, a decade later, that balance was broken. Edwin Hubble, peering into the skies above Mount Wilson, measured galaxies and found that they were moving away. All of them. Not randomly, not in some wind-blown chaos, but smoothly, uniformly, the further, the faster. The universe was expanding. Einstein was said to be frustrated. He removed the constant from his equations, calling it the biggest blunder of his career. Because if he had simply left his math alone, it would have predicted the expansion before Hubble ever saw it. But here is where the story quiets again, where the past folds softly into the present. Because decades later, in the soft light of supernova, in the dim galaxy's on the edge of time, astronomers discovered that the expansion was not just happening, it was accelerating, and suddenly, repulsive energy built into space didn't seem like a mistake anymore. It felt like prophecy. Einstein's blunder might have been brilliance, because what is dark energy, if not a kind of cosmological constant, a pressure in the vacuum, a property of space? It's not tied to mass, it's not dependent on matter, just quietly present everywhere. So scientists began to reconsider lambda, not just as a historical footnote, but as a real term with real consequences. They put it back into the equations, rebalanced the models, rewrote the narrative, and this time they listened to what it might mean. Lambda is a strange thing. It has units of inverse square seconds, a measure of curvature per time. It doesn't change with scale. It doesn't fluctuate with temperature. It's just there. A constant dot, simple in name, profound in implication. Because if lambda is real, then the vacuum itself has energy. Not energy caused by particles or heat, but energy of being, of existence. Imagine the ocean, still and quiet. No waves, no motion, but still, beneath the surface, there is pressure. That's lambda. The pressure of nothingness. The push of empty space. And just like water presses on the walls of a submarine, even when still, lambda presses on the universe, not inward, but outward, always outward. You may wonder, why does this matter? Why does a number from an old equation hold such weight? Because it may explain why the universe accelerates, why galaxies drift faster with time, why the fabric of space continues to stretch, and more than that, it may help answer the most delicate question in cosmology. What will happen in the end? If lambda is truly constant, if its value never shifts, then the universe will continue to expand forever. Galaxies will move so far apart that their light will never reach each other again. Star formation will slow. Black holes will evaporate. And trillions of years from now, all that remains will be cold particles in a silent sea of growing space. That future has a name, the Big Freeze. It is not violent. It does not roar, simply cools, stretches, and dims. It's the kind of ending that sneaks up like dusk, soft, patient, irreversible. And at the heart of that future is lambda, a symbol, a term, a whisper in the math that may determine the fate of everything. But of course, there are still questions. Is lambda truly constant? Or is it changing so slowly that we haven't noticed? Some models suggest that dark energy might evolve, that what appears fixed may in fact be shifting on timescales longer than we can measure. Others propose that lambda is only part of the story, a placeholder for something deeper, something like quintessence, or a hidden dimension, or a misreading of gravity itself. For now, the constant remains our best explanation, a quiet placeholder that fills the silence with structured, and in that silence, K, because it means Einstein's equations still breathe. They still speak to a universe in motion, and the constant he once regretted may be the one that holds the key to why the stars are moving away. So you lie still beneath that moving sky. You breathe slowly. The air in your lungs follows a rhythm just as natural as the rhythm of the cosmos. Inhale Exhale, like the universe, like space itself. And as you drift closer to sleep, you think of how strange it is that something as simple as a number carries so much mystery, that a single term added to balance a story could define how the story ends. And yet, what if the story isn't over? What if dark energy isn't constant? What if it shifts? What if it flows? You drift now through the fabric of the cosmos, not as a traveler, but as a listener. Dark energy is no longer a distant term. It breathes beside you, threads through you, holds your galaxy in its quiet palm. But tonight, we ask something new. What if dark energy isn't fixed? What if it changes? Not suddenly, not violently, but slowly, rhythmically, like a tide so wide you cannot see its edge. In the gentle vocabulary of physics, this idea has a name: quintessence, an echo of the ancient world. Long ago, the Greeks believed the heavens were made of a fifth element: earth, air, fire, water, and something else. A perfect substance, immutable, eternal. They called it ether. It's the element that filled the sky and cradled the stars. Today, the word lives on in a more scientific form, not as myth, but as metaphor, because in modern physics, quintessence is a candidate, a graceful possibility, an answer that breathes. Unlike the cosmological constant, which is static and unchanging, quintessence is dynamic. It shifts over time. Its strength evolves. Its influence grows or fades, depending on the shape of the universe. It is not a number, but a field. A field, in physics, is a quantity that exists everywhere, like temperature in a room, like pressure in the air. You don't see it, but you feel its consequences. A quintessence field would fill space like dark energy does, but it would not remain the same. It might have been stronger in the past. It might be fading now, or perhaps it is just beginning to rise. No one knows, but the idea opens a door. It suggests that the universe is not locked into one fate. It suggests that dark energy could behave like a living presence, not conscious, not willful, but responsive. Responsive to space, to time, to the age of the cosmos. You float now in that possibility. You imagine the field, not as a glowing fog, but as a whisper beneath all things, a gentle current beneath the ocean of galaxies. You can't touch it, but it touches the shape of everything in this model. The energy of the field depends on its potential, not political potential, not kinetic energy, potential in the mathematical sense. A landscape the field rolls across, like a marble on a hill. It may rest, it may roll, may wobble quietly, slowing as the slope evens out. This is how quintessence might work. Flows through a potential field, changing speed as the shape beneath it changes. Sometimes it may dominate the cosmos, other times it may retreat. And if it does, if its strength weakens, the universe may slow its expansion, may cool more gently. It may avoid the big rip, but that future depends on something we have not yet measured, because quintessence is harder to detect than a constant. A constant shows itself in uniform patterns, in clean curves, in cosmic background light, in red-shifted galaxies, but a changing field leaves subtle clues, tiny variations in how galaxies cluster, how light bends, how early structures formed. Astronomers search for these fingerprints. They look for signs that dark energy is evolving. So far, the data fits both models. Constant or changing, it remains unclear. The silence is still too deep. But the questions keep us watching, because quintessence offers more than just an alternative. It offers hope. It offers variability. It says the universe may not be on rails, may not be destined to end in cold isolation. It may surprise us. You imagine this field now, not as a force, but as a season. It's an invisible weather sweeping across cosmic time. Perhaps, long ago, this energy was fierce, a storm beneath young space. It slowed as matter thickened. It receded as galaxies formed. And now, in this era, stirs again, gentle, dominant, still changing. And still, we wait to understand what it will do next. Some versions of quintessence suggest a quiet decay. That dark energy may fade as space grows older, that the stars may one day gather again, not to collapse, but to return, to cluster, to rebuild. Others say the field may strengthen, not endlessly, but enough to stretch space until even atoms part ways. It's a delicate balance, and every future depends on the details of this shifting field. Some theorists even propose multiple fields, interacting energies, each with its own rhythm. A symphony, not a solo dot in that symphony. Quintessence plays the violin, high, delicate, changing with the tempo of space. And if this model is correct, then dark energy is not a mystery to be solved, but a melody to be followed, softly, over time, with ears wide open. It also opens doors to connection, because if dark energy can change, then perhaps it is connected to other forces we know. Maybe it links to gravity on vast scales. Maybe it speaks to inflation, that brief, breathless expansion at the beginning of time. Maybe it is the echo of that first, rapid stretch, still humming across the ages. Or maybe it's something else entirely, something new, a kind of energy we've never directly encountered. And that's the beauty of quintessence. It is both idea and question. It's both model and mystery. It invites us to wonder what else might shift beneath the surface of reality. If even space changes its nature, what else might time, mass, consciousness? Or are we just beginning to see how flexible the universe truly is? You rest now in that question. It doesn't need an answer tonight. Only your attention. Only your openness. The scientists still look. They scan the sky. They run simulations with parameters like breath. They write equations like lullabies for space. And they hope, not for certainty, but for clarity, for signs in the stars, for patterns in the void, for whispers in the math that suggests motion where once there was stillness. Because motion, even in the invisible, changes everything. And so we drift, with galaxies, with time, with energy that might be changing even now. And we ask, if dark energy can shift, can fade, can rise, then what else might live in the spaces we call empty? There is a kind of silence that isn't truly silent. Stillness filled with whispers. A darkness where flickers live. Tonight, we drift deeper into that kind of space. The kind that seems empty, but isn't. Not really. When you hear the word vacuum, you may imagine a void, a pure absence, okay? No particles, no light, no dust. It's endless, silent black. But in physics, the vacuum is not hollow. It's not empty. It's alive in its own quiet way. Even nothing, it turns out, has structure. You might think of a stage after the actors have gone, the props removed, the lights off. Still, the wooden floor holds the history of every step. The air carries a cue, memory of applause. The silence echoes with presence. So too does the vacuum of space. And the more scientists have studied it, the more they've come to realize there is no such thing as absolute nothing. Not in our universe. Even the emptiest parts of the cosmos are filled with invisible flickers, with ghostly pairs of particles that appear and vanish in tiny moments of borrowed time. These are virtual particles. They do not last. They do not stay. They are not directly observable, but their effects are real. In the quantum world, energy, in time, makes small compromises. For a brief instant, energy can appear where none existed, as long as it quickly disappears again. This is allowed by the rules. The uncertainty principle, kind of cosmic loophole. And so, in the vacuum of space, pairs of particles emerge, okay? Positive and a negative. A particle and its mirror. They exist for the briefest blink, and then they cancel. turning to the silence. Imagine fireflies in a forest you can't see. They flash once, then vanish. But if you look with care, you notice the forest is not truly dark. This sea of flickers is called the quantum vacuum, and it fills all of space, even between the stars. Even in regions with no matter, no light, no fields or forces, there is always this hum. And now, scientists ask, could this strange energy be the source of dark energy? Could these tiny, ephemeral dances add up to something real? After all, energy is energy, whether it's loud or soft, brief or lasting. If the vacuum holds energy, and it does, then that energy must have gravity, and gravity shapes the universe. But here's where the mystery deepens. When scientists tried to calculate how much energy the vacuum should have, based on known particle physics, the answer was too large, far too large. The expected energy was 10 times greater than what we observe. 1 with 120 zeros. That's more than the number of atoms in the entire universe. It's the greatest mismatch between theory and reality in the history of science. It's as if you measured the thickness of a hair as it got the size of the Milky Way. Something is wrong. Either the theory is flawed, or there is some hidden cancellation, a balancing act we don't yet understand. Because when we look at the universe, we do see vacuum energy, but only a little. Just enough to drive the acceleration of expansion. It's enough to fit the dark energy we measure. So why the difference? Why would the theory predict a sea of energy when the sky whispers only a ripple? Some believe the answer lies in the unknown parts of physics. New particles, new fields, new dimensions may explain the mismatch. Others believe we're missing a deeper rule, a law that cancels the vacuum's energy almost perfectly, but not quite, because perfection would lead to a stilled universe, and our universe is not still, it stretches. So maybe we are living in a delicate imbalance, a fine-tuned sliver of imperfection that allows for galaxies and stars and you. This idea that dark energy is just vacuum energy, toned down by some hidden mechanism, is still among the leading possibilities. It explains why dark energy is everywhere, why it doesn't clump like matter, why it stays constant even as the universe expands. But it also leaves us with deep questions. Why this amount? Why not more? Why not less? Is it coincidence? Or is there purpose hidden in the math? Some scientists turn to the anthropic principle. They say, if the vacuum energy had been stronger, the universe would have expanded too fast. Galaxies couldn't have formed. Stars would never gather. Life could not exist. And so, in the grand landscape of possible universes, we happen to live in one where the vacuum is just right for life to arise and to ask the question. It is not proof. It is a whisper. It's a suggestion that maybe the vacuum is part of a greater tapestry. Still others believe there is no grand design, that the vacuum's quiet energy is just another constant of nature, a number like the speed of light, unexplainable but measurable. And so we return to the vacuum, this not-so-empty space, filled with flickers, with motion, with possibility. It may be the most common thing in the universe. Most of the cosmos is not stars, not gas, not dark matter. It is vacuum. And if the vacuum holds energy, then most of the energy in the universe comes from nothing, from absence. And this energy, this hum of flickers, guides the expansion of space. It sets the tempo of the cosmic waltz. You lie still now on your bed, but you are not motionless. You drift on a sea of quantum whispers. Your body, made of atoms, floats within fields that stretch and shimmer. You are not separate from this emptiness. You are shaped by it. In some ways, the vacuum is your ancestor. The same fluctuations that push galaxies apart also shaped the early universe. They sparked the patterns that became stars. They seeded the clouds that gave rise to light. And so, in a quiet loop, you are born from a vacuum that breathes energy into the vastness of space. Tonight, as you close your eyes, imagine not a black void, but a soft hum, a field of gentle motion, particles flickering like candlelight on an infinite sea dot. This is not fiction. This is physics, and even if the numbers still leave us searching, the presence remains. The vacuum is not a blank page. It is the paper upon which the universe is written, and as space expands, perhaps that paper unfolds. More pages, more room, more quiet energy woven into the margins. And if so, then dark energy is not a thing apart. It is the note beneath every word, the echo beneath every silence, the rhythm that carries us forward. And as we move forward, one quiet question remains. If emptiness holds so much, what happens when distance begins to overpower gravity? There's a quiet kind of tension that shapes the universe, not the tension of struggle or noise, but of two great forces, pulling in opposite directions, neither fully winning, yet never stopping. Tonight, you drift in that tension. It stretches beneath you like a thread between stars. On one side, gravity is ancient, familiar, binding. It pulls everything inward. Planets, two suns. Moons, two planets. Gas clouds into stars. Galaxies into clusters. Gravity is the builder, the gatherer, the soft hand that shapes chaos into form. And on the other side, dark energy, subtle, silent, expansive. It does not clump. It does not gather. It does not tie anything together. Instead, it gently increases the distance between everything, not by pushing, but by stretching the very fabric that things rest upon. This is the cosmic balance. It's a slow dance of closeness and separation, a relationship measured in billions of years, in the way galaxies drift apart without ever turning around. In the early universe, gravity was winning. The cosmos had just been born, bursting from a singular point, rushing outward in fire and flame. But there was so much matter, so much energy, packed so tightly that gravity tugged hard against the expansion. It pulled clouds of hydrogen into filaments. It formed the first stars, then galaxies, then great clusters, and superclusters. The universe was expanding, yes, but at a pace slowed by its own weight. Gravity was shaping everything, but as the universe aged, it thinned. The same amount of matter spread across more space. Galaxies moved apart. Clusters grew more distant. And gravity, though still present, had less and less to work with. Meanwhile, dark energy stayed constant. Its influence did not fade with time. It did not thin out like matter. It remained steady, quietly working in the background. And then, somewhere around 5 billion years ago, a shift occurred. The balance tipped. Gravity, though still powerful, was no longer dominant. Dark energy began to pull ahead. The expansion of the universe didn't just continue. It accelerated, and the galaxies began to drift faster, not away from something, not towards something, but away from each other. Not because of motion, but because the space between them was growing. This is the loneliness of the cosmos. Imagine two boats drift on a vast lake. They are not rowing. They are not powered, but the water between them expands gently, and soon they are too far to see each other. That is how galaxies part ways. No sound, no explosion, it's growing silence. Gravity still works locally. It still holds your feet to the earth. It binds the moon to its orbit. It keeps the Milky Way together. Even galaxies within clusters remain loosely connected. But beyond that, the larger the scale, the more dark energy dominates. And so, across billions of light years, the distance grows. It is not a war. There is no conflict, just a slow, unstoppable divergence. And it raises a gentle question. What will the universe look like in 100 billion years? The answer is simple and strange. It will look empty, not because the galaxies have vanished, not because the stars have burned out, but because their light will never reach us again. The space between us will grow faster than the speed of light can close it. A horizon will form, not around us like the sky, but around our ability to see galaxies. We'll slip beyond that edge, one by one, till the night sky becomes darker and quieter than ever before. We will see only our own galaxy. The others, now trillions of light years away, will no longer be part of our story. The universe will seem strangely small, not in truth, but in visibility, and all because of the balance between gravity and dark energy, a balance that has tipped in favor of expansion. This idea that galaxies can drift so far we lose sight of them feels lonely, but perhaps it's also humbling, because it reminds us that the universe is not built for our seeing. It moves at its own pace, follows its own tides, and even now, galaxies that once shared the same corner of space now float apart in gentle isolation. We have names for some of them: Andromeda, Triangulum, Virgo Cluster, Coma, Super, Cer, each one a world of stars, one fading slowly into the dark. Even now, Andromeda is moving toward us, one of the few galaxies on a collision course. But that's only because gravity, locally, is still stronger than dark energy in the neighborhood of our galaxy. Closeness still wins, but beyond that, the farther you go, the more the expansion pulls, and eventually gravity loses. It's not just a concept, it's a pattern we can measure. The farther a galaxy gets, the faster it recedes. This is called Hubble's law, named after the astronomer who first measured it. But now, Hubble's law has a curve, not a line, because of dark energy. The rate of expansion is not constant. It increases, and that curve is the signature of this new cosmic era, the era of dark energy. Before, the universe was ruled by radiation, then by matter, now by something we can't even see that, and yet it shapes our destiny. Galaxies drift apart because space itself stretches, and that stretching has no center, no edge. It happens everywhere, all at once. Even now, light from the most distant galaxies struggles to reach us by the time it arrives. Those galaxies may have moved much farther still. We are always seeing the past. The past is always farther away. Still, we map what we can. We send telescopes to the edges of time. We chart the drift. We record the redshifts. We measure the silence between stars. And in that silence, we find patterns, structure, prediction, beauty. And so, you lie still, surrounded by galaxies you cannot see. They are there, they shine, but the light may never find you, because space, so soft and quiet, is growing between you and everything else. Still, there is no fear here, just the rhythm of things falling gently apart, just the soft inevitability of cosmic distance. You do not need to stop it. You cannot. You only need to listen. And as you listen, a question begins to rise. If we can no longer see these galaxies, if their light will never reach us again, how do we know they're there? How do we measure the invisible? How do we map the expansion of something we cannot touch? There are no rulers in space, no tape measures strung between stars, no hands reaching across the galaxies to count the miles between them. And yet, we measure, quietly, brilliantly, patiently. We map the invisible. We trace the fabric of space, not with touch, but with light. Light, in its quiet persistence, is the oldest messenger. It leaves a galaxy, crosses the dark, and reaches our eyes millions or even billions of years later. And tucked into each beam is a story. How far it has come, how fast the source is moving, how space stretched while it traveled, all written in color, in curves, in shifts, so subtle, only a telescope could hear them. You lie here now, still and resting, but your thoughts drift outward, across these tools of gentle science. Because how do you study what cannot be seen? How do you weigh what has no mass? How do you track the movement of things that seem too far to follow? The answers begin, as they so often do, with starlight. Long ago, astronomers noticed that light could be split, passed through a prism. It bent into color from red to violet, a rainbow of information. But it wasn't just a pretty arc. It was a code. Every star, every galaxy, every element that glows leaves a unique pattern of dark lines across the spectrum. These are absorption lines, arcs where atoms in the star have absorbed certain wavelengths of light, like a fingerprint, like a signature. And by studying those lines, astronomers learn to identify not only what something is made of, but how it moves. Because if a star is moving away, its light stretches, the wavelengths lengthen, spectrum shifts toward red dot. This is redshift. And if a star is coming closer, its light compresses, the spectrum shifts toward blue. Blue shift, the same principle that makes an ambulance siren change pitch as it drives. By dot, but instead of sound, it's light. And instead of miles per hour, it's light years per second. By measuring the redshift of galaxies far away, astronomers can tell how fast they are receding. And the more redshifted a galaxy is, the farther away it likely is. And the faster space is expanding between us. This is how we know the universe is growing. This is how we know that expansion is accelerating, not from watching galaxies fly, but from watching their light bend. It's like listening to a song that gets slower and softer. Not because the singer fades, but because the air itself stretches. The sound, and so, with each redshift, we measure the stretch of space. But to understand that stretch, we also need distance. How far is that galaxy? How far did the light travel? What was space like when the light left? This brings us to another gentle tool, standard candles, not made of wax, not with flames, but with brightness you can trust. The most famous of these is the type Ia supernova, a dying star in a binary pair, reaching a critical mass, collapsing into brilliance, an explosion so luminous it can outshine its host galaxy. But here's what makes it special. Every type Ia supernova has nearly the same Q intrinsic brightness, like identical bulbs scattered across the sky. And because we know how bright they should be, we can compare that to how bright they appear and calculate their distance. The dimmer it looks, the farther it is. These cosmic candles help map the cosmos. They give us distance, and their redshift gives us velocity. Together, they reveal how the universe expands. And when astronomers used this method in the 1990s, they discovered something they never expected. The most distant supernova were dimmer than predicted, farther than they should be, which meant the universe wasn't just expanding. It was expanding faster than before. Dark energy had entered the story, but redshift and standard candles are just part of the toolkit. There is also the cosmic microwave background, the oldest light we can see, a whisper from when the universe was just 380,000 years old, a time capsule, photograph of infancy. This faint glow fills the sky, even now, even as you lie here. It hums in every direction. It's nearly uniform, but not quite. Tiny fluctuations in its temperature tell us about density, about structure, about the shape and fate of the universe. We map these fluctuations in exquisite detail, and from them, we learn about the amount of dark energy, how fast expansion is happening, what kind of universe we live in. And then there is baryon acoustic oscillation, a quieter method, but no less powerful. In the early universe, before atoms had formed, there were sound waves, ripples through the hot plasma of creation. These ripples left an imprint on how galaxies are spaced, a preferred scale, a kind of cosmic yardstick, frozen into the structure of everything. By measuring that scale at different points in time, we see how the universe has grown, and again we find acceleration. Again, we find dark energy. It is everywhere in the data, not as a bright spot, not as a curve in space, but as a trend, a pull, a quiet deviation from what gravity alone would do. It is the silence behind the movement, and yet cannot see it directly. There is no telescope that can photograph dark energy, no instrument that can catch it in a bottle. We infer it, we map its shadows, we listen to what is missing, and we see its fingerprints in the paths of light and the shapes of galaxies. Science here is not about touching, it's about listening, about watching light, and trusting that it tells the truth, about understanding that the universe writes its story in code, and the code is light. You rest now within that light. You are part of the measurement. Your body, your atoms, your breath, all born from stars that obeyed these same laws. You live on a planet that traces its orbit in the grip of gravity, while the galaxy it belongs to is carried outward by the stretching of space. You are inside the data, inside the pattern. You are both the observer and the observed, and though dark energy remains unseen, its consequences shape everything, including the end, because once you understand how the universe expands, you'll begin to wonder how it might stop, or whether it will. If dark energy continues, what future awaits? Will the stars fade into cold silence? Will galaxies slip so far they no longer see each other? Will atoms themselves be torn apart? The next chapter gently approaches this horizon, not with fear, but with wonder, because the fate of everything rests on the answer. You lie still, the time moves forward, and the sky moves with it. Not quickly, not loudly, but with a silence so vast it cannot be contained in sound. The universe, tonight, feels like a breath held, and you, floating within it, are part of that breath, listening for how it might end, because every story, even one written in stars, has a final act, and though that ending lies billions of years away, we begin to see its shape. Its name is written not in prophecy, but in data, not in myth, but in mathematics. Its edge is carved, not by fire or collision, but by something softer, the slow, relentless pull of dark energy. So you ask gently, how will this all end? The answer is not a single path, but a collection of possibilities, each one painted by how dark energy behaves. Let's begin with the quietest, the slowest, the coldest. The big freeze-if dark energy remains constant. It continues to stretch space at an accelerating rate. Then the universe will never stop. Expanding galaxies will drift so far apart that their light can no longer cross the growing space between them. One by one, they will disappear from view, not because they fade, but because their light is lost to the stretching darkness. From Earth, the night sky will go quiet. The stars, we know, those bright constellations, those swirling galaxies beyond, will vanish. Eventually, only our own galaxy will remain, alone in the dark, and then even that will change. Stars burn fuel. They are not eternal, and in time they run dry. Massive stars live fast and die young, collapsing into black holes or exploding into supernova. Smaller stars last longer, trillions of years, but not forever. So, after enough time, new stars will stop forming. The gas that makes them will have been spent or scattered. The last stars will shine, dimly small red embers in a cooling cosmos. They too will go out, and then a long night will begin. A night where no new light is born. A night filled only with white dwarfs, neutron stars, and black holes, remnants. Even these are not permanent. Black holes, once thought to last forever, slowly evaporate. They release energy, hawking radiation, a whisper of heat into the cold, and over unimaginable spans of time, 10 years or more, even black holes vanish, nothing remains but particles, electrons, neutrinos, photons stretching into red. The universe, still expanding, grows larger, colder, an ocean of distance, a whisper of motion. No stars, no galaxies, no warmth. This is the big freeze, an end, not with a bang, but with the slow exhale of all things. A universe in which everything is so far apart, so diluted that nothing can happen. No gravity, no light, no time as we know it, only stillness. You rest now within that image. It's not frightening, not urgent. It lies so far ahead that even the earth itself will be gone long before it arrives. But it's there, and it teaches something soft, canned, important, that endings can be quiet, that sometimes the last sound is silence. But this is only one possibility. What if dark energy changes? What if it grows stronger? Then a new future opens. The big rip in this model. Dark energy doesn't stay constant. It increases, not explosively, but exponentially. Its strength doubles, then doubles again, and as it does, it tears more and more from the fabric of togetherness. First, galaxies drift apart as before, but then the galaxies themselves begin to fall apart. Gravity, which once held them, is no longer enough. The stars inside the Milky Way pull away from each other, then solar systems, then planets from their suns. And it doesn't stop there. As the strength of dark energy grows, it pulls harder. Suns begin to unravel. Planets split. Molecules stretch. Atoms lose their structure. Until, in the final moment, even space and time cease to be. Everything is ripped apart by expansion itself. The timeline depends on how fast dark energy grows. Some estimates place it in tens of billions of years, others much farther away, but all versions end the same way, with the unmaking of everything. You might expect this vision to feel violent, but in the scale of cosmology, even a rip can be slow. Imagine a painting growing wider and wider until the colors no longer touch, till the strokes fall apart, until the canvas itself is no longer a canvas, a silent disintegration. And still, there is one more idea, one that lies beneath them all. What if dark energy doesn't remain? What if it isn't constant? What if it isn't even real in the way we think? Some theories suggest that dark energy is temporary, that it rose when the universe reached a certain scale, but perhaps it may one day fade, shrink, change, and if that happens, the expansion would slow, stop, reverse. The galaxies that are now drifting apart would begin to draw near again. The universe would collapse inward. Galaxies fall into galaxies. Clusters merge. Stars collide. Matter compresses. All light moves inward toward a final center. The heat rises. The density grows. The scale shrinks until space itself curves into a single point. This is the Big Crunch, a reversion, a kind of cosmic inhale, a universe collapsing into its own seed. And from that seed, who knows? Perhaps nothing, perhaps everything. Some imagine that after the crunch comes another bang, a cycle, an eternal pulse, a universe that breathes, expanding and collapsing, again and again, forever. We don't know, and maybe we never will, because what lies beyond the fate of everything is not a place, but a question. Still, we measure. Still, we wonder. And still, the future remains open, because dark energy, whatever it is, holds the key. Its nature writes the final chapter, and we are only just beginning to understand the first lines. So you rest here, beneath stars that seem still. But you now know, stillness is not the rule. Everything moves. Everything drifts. Everything, someday, may dissolve. But not yet. There is still time, still warmth, still galaxies shining in the dark, still eyes to watch them, still questions to ask, and as we look forward, we'll also look back to the very beginning, because how the universe ends is linked to how it began. And in the background, faint but constant, a whisper from that beginning still lingers. A light, a song, the earliest sound ever made. You lie beneath the quiet of the night, feeling still, feeling whole. But beyond your walls, beyond your breath, the universe continues to move. And perhaps, somewhere in that motion, a thread is being pulled. Not harshly, not like a sudden tear, but slowly, steadily, quietly enough that no one would notice until the pattern begins to fray. This is the idea behind the Big Rip, a future not born in fire, nor collapse, nor cold, but in gentle, irreversible unraveling. It begins with a question. What if dark energy isn't constant? What if it's growing, not gradually, not harmlessly, but exponentially, doubling and redoubling its influence over time? Scientists call this a phantom energy model, a type of dark energy where the equation that governs its pressure suggests more than expansion. It suggests destruction. At first, it looks like any other era. Galaxies drift, clusters stretch, space continues its quiet reach. But then, dark energy begins to do more. It grows stronger. It begins to pull harder than gravity can hold. And then it begins to unbind, not just between galaxies, but within them. Stage 1, the separation of galaxies in this vision of the future. Galaxies don't just drift apart. They become unreachable, not metaphorically, literally. The light they emit can no longer make the journey across the ever-growing space. The acceleration outpaces the speed of light. And so, the stars vanish, not because they die, but because the space between them has grown too quickly for even light to bridge the gap. Imagine waving to someone on the shore, watching as their boat drifts farther and farther until even your voice can no longer reach. And then, even the memory of their silhouette fades. Now, imagine that boat was an entire galaxy. And now, imagine all the boats, all the galaxies, drifting forever away from one another. Stage 2. Galaxies come apart. Once galaxies are alone, dark, energy does not stop. It begins to work on smaller scales. Within each galaxy, stars orbit a central center. They are bound by gravity, a delicate, lasting dance. But if dark energy grows strong enough, even that dance falters. Stars are pulled from their slow revolutions. Gravity can no longer hold them, and so the galaxies come undone. What took billions of years to form, the arms, the spiral, the halo unfolds into starlight, drifting alone. Stage 3. Solar systems. Unravels still, the expansion continues. Now, it reaches into solar systems, into ours, into others. Planets no longer orbit their stars. Moons no longer orbit planets. Even the strong gravitational ties, those that bind Earth to the Sun or Jupiter to its moons, are eventually broken. The architecture of celestial harmony collapses into pieces, scattered not by explosion, but by distance. Everything that once circled now floats alone. Imagine waking in a sky with no moon, no sun, no direction, only stars moving away forever. But the Big Rip doesn't end there. Stage 4. The disassembly of stars as space stretches faster. Even stars feel the strain, the forces that hold them together, the balance between gravity and pressure, between collapse and fusion begin to tip. They begin to break apart, not in the way they do now when they run out of fuel, not in explosions, but in slow, structural collapse. Their very forms come undone by the expansion of space itself. What once was light becomes scattering atoms. Even the sun, which will have long cooled by then, is not safe from this pull. Stage 5. The breaking of planets eventually. The very bodies of planets, those orbs of rock and gas and metal, are torn apart. Mountains dislodge, cores separate, crusts crumble, not from inside, but from the stretch of space outside them. The force of dark energy now exceeds the atomic strength of matter. It pulls apart everything. The Earth, if it was still there, would split not in halves, but into unbound dust. But even this is not the end. Stage 6. The death of molecules. Once planets and stars have disassembled, dark energy reaches into matter itself. Molecules, once stable, the basic building blocks of life, can no longer hold together. The chemical bonds that keep water, that keep DNA a spiral, that keep oxygen whole, snap. Each molecule becomes separate atoms, drifting alone in the accelerating void. But even that is not the final chapter. Stage 7. The final rip and jolly. Space grows so fast, so swollen in its own momentum, that even atoms fall apart. The nucleus, once held together by the strong force, nature's most powerful glue, can no longer resist. Protons and neutrons split into quarks. The quarks themselves, fundamental, indivisible particles, are finally isolated. Even the quantum fields that shape particles are pulled so far apart that identity itself is meaningless. All things, once stitched together by interaction, are now utterly alone. No particles, no relationships, no structures, not even space or time as we understand them can survive. This is the big rip, not a moment, but a timeline, a series of partings, of gentle unravelings that ends with the unmaking of everything. When does this happen? Phantom energy is real, then perhaps in 20 to 30 billion years, or sooner, or never, because we don't yet know whether dark energy behaves this way. We haven't seen its strength grow, only that it seems to stay constant for now. But physics allows for the possibility. The equations do not forbid it, and that's why the Big Rip remains a chapter in our cosmic library. Not because it will happen, but because it could. And in its quiet horror is also a strange beauty, that even the end can be soft, that even the death of all things might come not with screaming, but with silence. The silence of space pulling things apart. The silence of separation so complete that no return is possible. But even in this vision, you are not small. You are not meaningless, because you are one of the few who can even imagine it. To ponder the end, of time is to stand outside it, if only in thought, and that is a kind of miracle. So you lie here, wrapped in stillness, while galaxies spin quietly above. You are not at the end. You are in the middle, the part of the story where stars still shine and questions still rise, the part where science whispers soft maybes into the dark. And from here, you can turn back to where it all began, because the clue to the end may live in the first light of all. The quiet background hum that has been with us since the beginning. It is still singing, still echoing. And if we learn to listen, really listen, we may hear what it's trying to say. There is a sound older than memory, older than earth, older than stars. It doesn't ring like a bell. It doesn't crack like thunder. It hums softly, faintly, evenly. It fills the sky, not in flashes, but in quiet glow. And though your ears cannot hear it, it has never stopped singing. This is the cosmic microwave background. Not a sound in air, but a light stretched into coldness, echoing the very first time the universe was able to speak. To understand that light, we must go back farther than galaxies, farther than stars, to a time when the universe was young and hot and full of fog, a time when photons, particles of light, could not travel freely. They were trapped, scattered constantly by free electrons and nuclei, bouncing endlessly through a dense plasma like sunlight through storm clouds. The universe then was not dark. It was blinding, opaque, like the inside of a flame. But the flame was cooling. As space expanded, the heat spread thinner. Atoms began to form. Electrons settled into orbit. Light was no longer trapped. It was set free. And in that moment, some 380,000 years After the Big Bang, the universe became transparent. The fog lifted, and the first light of the cosmos began its long, patient journey. That light is still traveling, still crossing space, still reaching us from every direction. We call it the cosmic microwave background, or CMB for short. It is not light you can see. Over the billions of years, its wavelength is stretched from glowing white to soft microwave radiation, from fire to whisper. But it is still there. It's all around you. Not from one star, but from the entire early universe. If your eyes could see microwaves, the sky would glow, not with stars, but with an even, gentle haze. A background, a cradle of photons that tells the story of where we began. And the story it tells is rich with detail, because the CMB is not perfectly smooth. It has ripples, tiny fluctuations in temperature and density, differences of just a few millionths of a degree. But in those ripples are the seeds of structure. Where there were slight overdensities, gravity pulled harder. And from those pulls, galaxies formed, clusters grew, stars were born. In the quiet unevenness of the background glow lives, the blueprint for everything that came after. You are part of that pattern. Your atoms follow the paths carved in that first light. But the CMB doesn't just tell us about the past. It tells us about the future, because its ripples also reflect the influence of dark, its energy. They record how space has stretched since that light was released. They record how fast the universe was expanding, how much matter existed, how much dark matter, how much dark energy. The precise measurements of the CMB taken by satellites like WMAP and Planck have given us some of the most accurate cosmological data ever gathered from them. We learned the age of the universe too within a few million years. From them, confirmed that dark energy makes up about 68% of the cosmos. From them, we confirmed that the universe is flat, not curved like a sphere or bent like a saddle, but flat on cosmic scales, as if geometry itself was ironed smooth by inflation. All of that from a faint glow just a few degrees above absolute zero. It is astonishing. But what's more, that background light still listens. It carries the echo of every moment that came after. Not directly, but in how it has changed as it traveled. Think of it this way. Imagine a violin string, plucked once and left to vibrate. Now imagine walking away from the string for billions of years, listening as its tone shifts with distance, with echo, with the spaces you pass through by the time you stop. The song is faint, but you can still hear how it began. That's the cosmic microwave background, a vibration across the fabric of space, altered slightly by every hill and valley. It crossed by every cluster of galaxies, by every gravitational tug, by the quiet push of dark energy. It is not just a memory, it is a map, and scientists read it with extraordinary care. They study its anisotropies, those tiny variations, and extract from them clues about the birth and growth of the universe. They look for polarization patterns, for signs of B-modes, for hints of gravitational waves left over from inflation. They calibrate the direction, the frequency, the distortion, and they refine our picture of what the universe is made of, how it evolved, and what may come next. You might wonder, how do you listen to such a faint hum, with instruments placed beyond the atmosphere? Satellites like COBE, WMAP, and Planck have scanned the sky with microwave detectors, turning the invisible glow into temperature maps. These maps are stunning, swirls of blue and red, not of color, but of cold and warmth, differences in temperature as small as 1 part in 100,000. And yet, they hold the shape of everything, because that unevenness is what allowed its gravity to gather matter. And without it, there would be no galaxies, no stars, no us. The CMB is not just noise. It is the heartbeat of the early universe, slowed and stretched across billions of years. And tonight, you float in it. Literally, every part of you is bathed in this ancient light. Every second, about 400 photons from the cosmic background pass through every square centimeter of your skin. They do not harm, they do not warm, they do not even flicker. But they are there, old, patient, endless, and they connect you to the beginning in some strange, profound way. You are always in contact with the moment the universe became. Transparent, always touching the edge of time. And if you could listen, truly listen, you might hear what the cosmos has been trying to say since that first breath of light. You might hear not words, but rhythm, not speech, but meaning. Because this background tells us something essential, that the universe remembers, that it carries with it a record of its birth, and that we, small as we are, have the tools to read it. We cannot hold dark energy. We cannot see it, but through the lens of early light, began to understand its fingerprint, because even back then, just 380,000 years after the Big Bang, its presence shaped the future. It shaped how space expanded. It shaped how clusters formed. It shaped how far the cosmic background would stretch, and now shapes how we listen, because the answers may not lie in what we see, but in how we see it, in the shifts, in the ripples, in the harmony between light and space. So tonight, as the real sky darkens, remember that behind the stars is a softer sky, one you cannot see, one you cannot touch, but one that has been glowing since the beginning. A lullaby for the universe, still playing, still heard, and perhaps still guiding us toward the next question. What lies beneath this mystery? What force, what structure, what unknowable field gave rise to the dark energy we now feel? The sky is quiet again. You've traveled through galaxies in silence, through stretching space and vanishing stars, through ripples in ancient light and the fading hum of beginnings. And now we return to where you always were, here, beneath the same night sky. And yet something has changed. Not in the stars, not in the moon, not in the breeze that brushes against your face, but in you, because you now know that nothing about the night is still. You now know that the sky you see is drifting, pulling apart, coming more distant every second. You know that the galaxies have grown lonelier, that light takes longer and longer to find its way to you, and that the force responsible is not violent, not visible. It has no shape, no center, no face, only presence. It does not stir the leaves. It does not push tides. It does not hum against your skin, but it moves all things, gently, endlessly, everywhere. We call it dark energy. But even that name is an offering to the unknown, a placeholder, a soft name for something we cannot describe. We've called it a constant, a field, a property of space, a whisper in the vacuum, a phantom in the equations. But in truth, we do not know what it is. We only know what it does. It causes space to stretch. It causes light to drift. It causes distance to grow between things that once touched, and it may shape how the universe ends. But beyond that, only questions remain. You are not small for not knowing. You are vast for asking. That is what makes you human. You are part of a species that can listen to light from 13 billion years ago. Ask what it means. You are made of atoms that were forged in stars, the very stars now moving slowly out of end, reach, dot, and still you wonder, still you look up, still you listen, even as the cosmos grows quieter, cooler, more spread apart. Your curiosity remains intact. That may be the universe's greatest miracle, that something emerged from dust and heat that now asks what it means to be dust, what it means to drift, what it means to end. Even as we admit we do not know, we lean forward. Even as we float in a universe that may stretch forever, we stay tethered to the desire to understand, and that, perhaps, is what cradles us, not the certainty, but the mystery, not the answer, but the gentleness of not having one, because there is something beautiful about living in a question, not one filled with fear, but with awe. You now know that most of the universe is invisible, that most of its energy is hidden, that what we touch, what we measure, what we see is only the surface. Beneath that surface is silence, stillness, a presence we cannot name, and yet it holds us. It holds the galaxies in its breath. It writes the rhythm of expansion. It sketches the outlines of what will and will not remain, and we rest gently inside its hand. Dark energy is not a villain, not a monster at the end of time, not a destroyer. It is more like a quiet tide, soft undercurrent beneath the boat of the cosmos. You may never feel it, but it carries you just the same. And as you drift into sleep, that thought becomes a kind of peace, that even the most unknowable things are not outside of you. They are around you, within you. Your atoms obey the same laws. Your breath follows the same expansion. Your thoughts are shaped by the same curvature that governs starlight. And when you sleep in the arms of a universe still unfolding. What if it never stops? If dark energy continues to stretch space forever? Then we live in a poem with no final line, only quieter verses, only dimmer lights, only fading echoes of what once was close. And what if it stops? What if dark energy shrinks, fades, or changes? Then we live in a universe with new surprises ahead, new futures, new beginnings, written from the end. But either way, you are part of it. You do not need to be certain to belong. You only need to wonder, to sit, as you do now, beneath the stars, to listen, as you have tonight, to the whisper of physics woven into space itself. To remember, as you close your eyes, that the very emptiness you fear may be full of more than you imagined, that the silence may hold a hand, that the mystery is not meant to be solved all at once, maybe not ever. Maybe some mysteries are meant to be companions, the kind that walk beside you, quietly, for your whole life. Dark energy is like that. It does not demand. It does not shout. It simply continues. It flows. It is dot, and in that quiet presence, there is something comforting, because we do not need all the answers to feel at home in the cosmos. We only need to listen with care, to notice, to rest inside the question. And so, as you let your breath slow, as your muscles loosen and your mind grows still, you remember you are not alone in your not knowing. You are one with the galaxies, one with the fabric of space, one with the quiet unfolding of time itself. And even as the stars drift apart, the light takes longer to reach your eyes. You are cradled by the same rhythm that carries them. The universe may be vast, but it is not indifferent. It holds you, softly, firmly, without need for definition. Tonight, okay, as you close your eyes, you return to that holding, not to solve, not to name, only to rest. Let the galaxy spin. Let space stretch. Let the quiet deepen. You are safe inside the question, and the mystery that moves the stars moves gently through you, too. There is a moment, just before sleep, when your thoughts loosen, when your breathing becomes quieter than the room, when the boundary between you and the sky feels thin. Let's stay there, in that moment, because this story, this journey through stars and silence, through cosmic expansion and dark energy, was never just about space. It was about you, not the small you, not the you defined by a dress or calendar, but the deeper you, the you that existed long before you had words for it, the you that feels quiet in the presence of mountains, that hushes when the night sky opens, that listens to questions without rushing toward answers. That you has always been part of this story, because everything that stretches, everything that glows, everything that fades in the dark includes you. Your atoms came from stars. That isn't poetry, it's chemistry. The iron in your blood, the calcium in your bones, it's the oxygen in your lungs. They were all formed inside the hearts of stars that exploded long before our sun was born. And those stars, those furnaces of fusion, were shaped by gravity, okay? By motion, by time, by the expansion of space that began at the beginning, by the quiet pressure of dark energy, pulling everything a little farther apart. So no, you are not on the edge of the universe. You are in it, of it, written into its fabric. You are part of the question we've been asking all along. What is this place, and what is it doing? You are not simply a spectator watching galaxies drift. You are drifting to dot your very cells are suspended in a medium that is stretching beneath them. Every second, the space around you grows in ways too small to feel, but not too small to matter. You do not notice, but the math does. You do not sense the stretch, but the light from distant galaxies shows its effect. You live in a world that is being pulled gently apart, and yet you are whole. Isn't that remarkable? Is that in a universe so devoted to distance, you can still feel close to anything at all? To a song, to another person, to the quiet of your own breath. That is not a contradiction. It is a gift. The universe may stretch, okay, but it also binds. The same physics that let galaxies drift also allows molecules to form, okay? Atoms to hold, hearts to beat in rhythm. There is no you without expansion, okay? But there is also no you without gravity. You are a moment of balance, temporary knot in a cosmic thread. You are a stillness in motion, a breath in a breathing sky. And yes, one day, the stars may fade, the galaxies may vanish. Time may outlast everything that once glowed, but tonight, you are here. In the golden window between silence and silence, between the past and what lies beyond it. And that window is wide enough for a life, wide enough for love, wide enough for wonder, wide enough for this very thought, that even though dark energy pulls everything apart, it also reveals how deeply everything was once connected. You cannot be stretched unless you were once whole. You cannot lose something unless you were once close. The distance proves the intimacy. The expansion proves the closeness that once was. And maybe, just maybe, the same is true for you. Maybe the spaces you feel in your heart, the ones that ache, or the ones that long, are not signs of failure, but signs of love. Proof that something meaningful once lived there, and that something might still return, if not in form, then in feeling, if not in fact, then in memory. So even as space grows, you do not grow smaller. You grow more aware, more attuned, more open, because now you know how precious it is to be here. For even a while, to have light reach you from across time, to share this moment with stars still visible, with galaxies still whispering in the dark. You are alive in the part of the universe where the echoes still arrive. You are alive in the part of the story where questions are still being asked. You are alive in the soft unfolding of mystery. What happens next? We don't know. Will the universe freeze, rip, cycle, collapse? Perhaps none of these. Perhaps something new awaits in the unknown chapters. But you will not see those endings. And that, too, is beautiful, because what you have is now. You do not need to hold the future to appreciate the present. You do not need to grasp the answers to be held by the questions. You do not need to see the edge of the universe to feel its warmth. And tonight, as you lie still, listening to the rhythm of your own breath, remember this: the stars you see are not just light. They are memories. They are time arriving late, but still arriving. And you are like them. You are not just here. You are becoming. You are the light from a past still making its way forward. You are the energy of generations of questions. Carried gently into this moment. Let yourself rest there. Let the space stretch. Let the mystery grow. You are safe within the unknown. The universe is not finished, and neither are you.